Okay, sorry about that. My timer timed out, so I wanted to get all of this on one video, but we'll go into two. So our final electrode placement setup is quad polar. And in this case, we have two channels. So each channel is then divided into two pads, so two leads off of each one. So two sets of electrodes, four electrodes total, all of them are active, and each pair comes from its own channel. We will use this most often with IFC, though you can see it on when we just set up two, maybe TENS treatments, and we want them to cross or be parallel to each other, congruent or parallel. So we can run parallel or have them cross at the center. Usually we use this for larger areas, because if you're trying to do something like at the wrist or something small, you're not going to have room for all four of these pads. So we do it a lot in the back or the shoulder or the knee or the quad or the hamstring or something like that. Okay, so a little bit of safety talk. So we talked about this in kind of our administrative chapter already, but just a little review. You have to kind of understand the magnitude of the current you're producing with these e-stim units. So we usually measure them in either milliamps or microamps. Most of our sensations, our intensities, we're going to be focused right in about here, about 1 to 15 milliamps of intensity, where we're trying to get that tingling sensation or a muscle contraction. But it's a fine line between that and potentially a painful shock. And so we want to make sure our machine is working right, that we're not letting any flux of amperage come through. And so we'll do that with protecting it with a circuit breaker and with a GFI. And then you can see how it progresses from there. So a circuit breaker, like we said, responds to a specific amount of a current. And that current is usually somewhere around like 2 or like half an amp or somewhere around there, where basically if there's a surge that comes through, it trips the circuit and opens up a valve or like a little lever, and that stops the current from being able to flow because it's not a complete circuit anymore. It opens it up. A ground fault interrupter is just a fancy and more specific for usually a single outlet type of circuit breaker. So it goes for very small, abrupt increases in current. So it takes less than 0.025 seconds to trip the circuit breaker, and usually that's as small as 5 milliamps. So any places that could be potentially dangerous, especially modalities also with water, should all have ground fault interrupters. So all the electrical modalities should be connected to one. And then, as always, what we talked about in our administration chapter, you want those electrical modalities to be inspected annually.